All right, for problem 14, it says the polynomial function f has selected values of its second derivative, f double prime, given in the table above. Which of the following statements must be true? A and B have something to do with increasing and decreasing. C, local, extreme value type stuff. D, point of inflection. And E, the graph changes concavity. Okay. So the first thing I would do as a test taker would be to hope that the answer isn't A, B, or C, because they didn't give me information about f prime, and I would need information about f prime to be able to figure out anything about A, B, and C. So I'm just hoping it's not A, B, or C. So I'm hoping that I can rule D or E in, if that makes sense. And so let's just kind of think about this. The graph of f has a point of inflection at x equals 1, and the graph of f changes concavity on the interval from 0 to 2. So it's going to be easier to rule E in than D. So I'm kind of hoping that it's E. If not, we can come back and think about D. So E, the graph of f changes concavity. Well, your graph is concave up when f double prime is positive, and it's concave down when f double prime is negative. So really we could just look at what f double prime is and look for it to change sign. And so I could see that you had something that was positive. You had a positive second derivative, and then it changed to a negative somewhere in this interval from 0 to 2. And so right there we could rule E in. And then let's talk about why not D here. The graph of f has a point of inflection at x equals 1. The reason that we wouldn't want to rule that one in is because you don't know exactly what happens between 1 and 2. You know that the second derivative was 0 here, and then it was negative later. But maybe in the interval from like 1.5 to 1 3/4, maybe the concavity was positive again and then negative again somewhere in that interval. And so you don't really know that your graph changed concavity right at 1. It maybe changed, later. Anyway, so you could have had a positive second derivative, 0, and then a positive again, 0 again, and then it went to a negative. If that makes sense. So that is why I would rule E in pretty easily and then feel pretty good about leaving all the rest out. Okay, let's go ahead and get problem 15 done in this video as well. It says if f of x is natural log of x, that quantity squared, then what is the second derivative of that function evaluated at the square root of E? So first we're going to need to get the second derivative in terms of x, and then we'll just plug the square root of E in. So since f of x is the natural log of x quantity squared, let's take the first derivative. So the outside function is basically the square function, so we'd use power rule on it to the first. And then make sure you multiply by the derivative of the inside function, and the derivative of natural log of x is 1 over x. And then up to you how you want to clean it up. You could write it as 2 times the natural log of x over x, I guess. I don't know, that's kind of cute, right? Anyway, and then second derivative in terms of x, I don't know, I think I'll just go ahead and use quotient rule for it. So low d high would be 2 times 1 over x minus high d low would be 1, and then over the bottom squared we go. And then I'll go ahead and clean it up a little bit. So f double prime of x ends up being, looks like 2 minus 2 times the natural log of x all over x. And then f double prime of the square root of E would be 2 minus 2 times the natural log of the square root of E over the square root of, oops, did I forget a square? I did. Square root of E squared. And then natural log of the square root of E, keep in mind square root is like 1/2 power. And so, so this piece right here is asking e to what power would be e to the 1/2 power. So this whole thing in the circle there equals 1/2. So I would end up with 2 minus 2 times 1/2 all over, and square root of e squared is just e. Anyway, and then the top simplifies out to be 1, and that's how you could get option A here, 1 over e.